All right, so today we're talking about graphing quadratics from intercept form. All right, you need to know there are two approaches to graphing quadratics in this form. All right, step one, graph the x-intercepts. Find the vertex by splitting the difference to find the x-coordinate and plug the x into the equation to find y. Okay, this sounds complicated, but really, this is probably the easiest way to do it, the least time-consuming way. All right. Option two, multiply so that the equation is in standard form and use the negative b over 2a formula to find the vertex. That one's a lot more work, but you can do it either way. All right, so let's look at this. The x-intercepts, to find the x-intercepts, remember the x-intercepts are where the line, your parabola, crosses the x-axis. To find them, we're going to set each of my factors equal to 0. So x minus 3 equals 0. X minus 7 equals 0, right? So I add 3 to both sides. So x equals 3. Add 7 to both sides. So x equals 7. All right, so my x-intercepts are at 3 and 7. We can actually plot that. So we're at 3 and we're at 7. When it says split the difference between them, what's halfway between there, right? If I go 1 here, 1 here, 1 here, 1 here. Oh, hey, that's the middle one. So our middle term we know is going to be where x equals 5. So our vertex, the x-coordinate is 5. And then we need to plug that into our equation to find out what y equals. So let's do her. So y equals 5 minus 3 times 5 minus 7. Well, 5 minus 3 is positive 2. 5 minus 7 is negative 2. So positive 2 times negative 2 is negative 4. So my vertex is at 5, negative 4. All right, 1, 2, 3, 4. All right, now I can do my 1, 4, 9 table just like I've done before. All right, A is still the same thing. Okay, whatever you've got here is your A. So in this case, it's still 1. So we're still 1, 4, 9. All right, so starting here, we go 1 in the x direction, we go 1 here, 1, 1. If I go 2 in the y x direction, I go 4, 1, 2, 3, 4. Hey, look, we already have our dots there. Go 3, and I need to go 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, and then we can draw our parabola. All right, trying to make yours a little nicer looking than mine. All right, let's do the next one. Okay, x minus 4 equals 0. X plus 2 equals 0. So x equals 2 and x equals positive 4. So our x-intercepts are at 2 and 4. And actually, let's make these and signs instead of commas just so we don't think that they're coordinates. So at 2 and 4, well, what's halfway between that? 3. So my vertex is at 3 something. So let's plug 3 in. So y equals 3 minus 4 times 3 plus 2. Well, 3 minus 4 is negative 1. 3 plus 2 is 5. Negative 1 times 5 is negative 5. So my coordinate for my vertex is 3, negative 5. So 1, 2, 3, 4, 5. There we go. Same 1, 4, 9 table. Actually, we don't even need to do a 1, 4, 9 table, do we? We have 3 points, right? You see this? All right. All right. Same thing here. You notice that this is slightly different. It's all okay. So each piece equal to 0. All right, so my x-intercepts are at 0 and 4. So 0 and 4. Halfway in between there is going to be 2. So plug that in. 2 times 2 minus 4. 2 minus 4 is negative 2. 2 times negative 2 is negative 4. So negative 1, 2, 3, 4. Draw my parabola. Are y'all getting this? It really is just as easy as it seems. Okay, next I want you to look at some inequalities here. All right, so for this inequality, I have negative x plus 5 and x plus 7. All right, so set each piece equal to 0. X plus 5 equals 0. X plus 7 equals 0. So x equals negative 5. X equals negative 7. So my intercepts are at negative 5 and negative 7. So negative 7, negative 5, split the difference is going to be at negative 6. All right, plug that in. So y is greater than negative times negative 6 plus 5 times negative 6 plus 7. All right, don't forget to bring down this negative sign. All right, negative 6 plus 5 is negative 1. Negative 6 plus 7 is a positive 1. All right, this negative sign out here, remember that there's a ninja 1 here. So negative 1 times negative 1 is a positive 1. Times 1 is 1. So our vertex is at negative 6, 1. So negative 6, 1. And you notice that predictably, this is an upside down parabola. All right, but we're not done here because this is an inequality, right? So inequalities, we notice our symbol, our operator here. This is just greater than. So this tells me that I need to have a dotted line, right? So let's make this line dashed. That also tells me I want to shade where all the y's are greater than my vertex. So looking at my vertex, the y's greater than 1 are up here. So we're going to shade on this side. And that's all there is to it. Just apply what you know to put the two things together. Good luck with your homework, guys. And as always, email me if you have any questions.